We are now recording. So what can you see? Can you see, which screen can you see? Can you see the pressure loss screen? So we're good. Okay, so we're going to go over the pressure loss method, or why or how to use the pressure loss method. And we just finished counting for this Hotel California, I call it. We counted how many fixed units, total fixed units at peak demand for this building. We just did it. Does anybody remember?
208.5.
So we counted 208.5 fixed units for this whole building, which was 12.8 for the top floor, 15.8 for the third floor, 127 fixed units for this floor, and 52.9 fixed units for the first floor and the basement fixtures. That totals 208.5 fixed units. So we know the total load. But now the question is, do you use the small commercial method or some other method, or the pressure loss method? We're going to try and figure this out. So in order to figure this out, you go to the back of the code book, like I told you previously, and we're looking at this chart right here. Right now, what I did is I used some of the same numbers on this animation as the chart at the beginning, so you'd understand what they're talking about. So we're going to go to step 1C. Step 1C, these three figures, where it says minimum static pressure, pressure losses for the service, and adjusted pressure at the water service entry to the building. So you know what this 565 is? Well, let's look at 1C. Here is 1C here, everything in blue. Step 1C. So where it says 565 right here, that's the pressure at the water main. So that's right here. Here's your pressure at the water main. So, and then notice how the water main and the water service is 2.5 meters deep. What's 2.5 meters in feet? Approximately.
8.
That's about 8 foot deep, right? So that's deep enough to be in the frost for here in Canada, right? So 2.5 meters deep and 565. So I'm using the same numbers as them, 565 at the main and 2.5 meters deep. So as the water line goes up to the building distribution, 2.5 meters is a pressure loss of 25 kPa, isn't it? 2.5 times 10 kPa for every meter, right? And so you lose 10 kPa for every meter. So 2.5 meters would be 25 kPa. So that's what we did here. Our elevation difference from the water main to the building shutoff is 2.5 meters. And so instead of 565 that we had down here, 565, it will now be minus 25. It'll be 540. That's what this means right here. Does everyone get that? That's what it means. We're just adjusting the pressure loss. 540. And I'm using the same numbers as in your code book. You're going to see I'm going to change it a bit because they use a different building. So we're going to go to step 1D, which is using that 540 kPa at the building pressure, or at the main building shutoff. And then you'll see in parentheses here, or in brackets, these three numbers here. We're going to figure out three different kPa numbers. We're going to add them together. We're going to subtract it from the adjusted pressure and get a new kPa. So let's look at it. The first one is 20 kPa pressure loss for a water meter, a pressure reducing valve, or a backflow preventer, or any other losses. So let's take a look at it. Let's go here. And here is the same thing. So we have a water meter. I don't have a pressure reducing valve on here. I didn't need one, so I didn't have it. So I have a water meter and a double check valve assembly. That's what this is, meter and DCVA pressure. Loss is 20 kPa. Still the same as this number here. Everyone get that? But now we're going to change it slightly, because this next one says, then you have to add the pressure loss of 35 kPa, and that is losses for system height. What system height are we talking about? What is the system height? From where?
Furthest outlet.
So from where to where on the building?
Shutoff valve of the main feed in the bottom floor up to the top floor to the furthest fixture.
So that's what we're talking about, is from this main building shut off, total system loss to the top. Now, this is where these numbers are going to change, because their total one is only 35 kPa. So how many meters would that be?
3.5.
That's only 3.5 meters. So
which is
the
roughly
loss,
one floor.
yeah, the loss in their building would be like this. It would be, let's do my measuring tape here. On theirs, it would be from this building shut off. Where's 3.5? 3.35, there's 3.5 meters, like one floor. And my building is, I didn't want to use a one-story commercial building. I've got like 1, 2, 3, 4, 5 stories, right? So that's where it's going to change. So theirs is 3.5 meters. Ours is going to be, let's measure it. Ours is going to be, and we'll just do approximate from the building shut off here. I'll go to here. Around, can everyone read that? 14 meters, we're going to say. So 14 meters times 10 kPa, what's the pressure loss here?
140 kPa.
140 kPa. So let's check it out. So that's the difference. Theirs said 35, and mine is going to say 140 kPa instead of 35. So we're going to add 20 kPa and 140 kPa on this taller building. And this is going to be the same for both. So let's look at in brackets on theirs. Theirs says 105 kPa, which is the minimum pressure necessary for every fixture to work on each floor. What is 105 kPa? It's going to be the same. This is going to be a constant you have to remember. It's going to be the same on mine. What is 105 kPa in PSI divided by 7?
15.
Remember that number I kept saying before in the downfeed system, that this is the minimum pressure they're using in the code, 15 PSI for every fixture on the floor. In reality, nowadays, mechanical engineers are using 25. So that number's 25 PSI. That number is probably going to change in the new 2020 code. What's 20 PSI in kPa, or 25 PSI in kPa? 25 times 7.
175.
So that would be, that's probably, number is probably going to change, but right now it's 105 and we're going to use the same. So we add these three numbers together, 20 kPa, 140 kPa, and 105 kPa, and that equals 265 kPa of pressure loss that you're going to have to take away from the 540 at the building. And that is going to equal 275 kPa. So their number is 380. Our number is 275. Does everyone get that step? Mine is slightly different because I got a 4 or 5 story building. So now we're going to go to step E. Their 380 and our 275, we're going to put down here. For the total, now this is going to be the total pressure available for friction loss. And this is what we're going to do for friction loss. In their case, they had a number of 114, which was the total developed length from the building shutoff to the farthest fixture times 1.5 for fitting loss and additional losses if insert fittings are used. Their number came out to 114. Well, their number is different than ours. So we have 275 here. Let's go and figure out what ours is going to be. So what is this? This is step 1E. So now we're going to go to the red one, which is step 1E. There's our total available pressure for friction loss, 275. We're going to divide the 275 by the total developed length from the building shutoff to the farthest fixture times 1.5. So what is our total? So in other words, if I took my measuring tape and measured from here all the way to the farthest fixture, and I've already done it, it comes out to, I think, 40 meters. So 40 meters times 1.5, just like the 1.5 they're using, but they had a different one. And ours is going to end up being, well, 40 times 1.5 is 60 meters. So then all you do is you take the 275 and divide it by 60 meters, and you will come out to 4.5 kPa per meter. That's what our final figure is. So our final is 4.5 kPa higher than 2.6 kPa? Yes, it is. And so that means you use table F. So our project means we are going to use table F to size the water service in all the branches. So let's go over table F. This is what I want you to do. In your code book, see where it says 2.4? Just like on the simplified method, mark cold there. Right? See how it's marked cold? That's just like on the simplified table. Remember that 2634 table? Mark cold. And then on the hot one, mark 1.5. I've told students in the past that I've heard they never asked a question for hot, but until recently. So we will size that separately. We're just going to size the service right now. So if we're going to size the service, let me get Anna Date over here to help us out. So I can just do it right on it. So we're going to size the service. Does anybody remember the total fixture load at peak demand for this building?
208.
208.
208. So you cold, you go down the 2.4, and that would be 208. You'd have to go to the 265, and voila, there is the size of our service for this building. And this table now is just like the simplified method. It's pretty easy now that we know we're going to use it. So it's a 2-inch service. And we're for any cold distribution branch service. Now because we've already done all that pre-figuring out, we're going to use this column for everything, for a cold, a combined, or the service or distribution branch. So it's going to be pretty easy. So watch, check this out. I'm going to move my anecdote down there so I can move my diagram around better. Get back on the mouse. And here we go. So that means this service right here is going to be 2 inches, right? Let's check this drawing out a little bit better, this animation. So here's a couple of things. Here's our curb cock, right? That's approximately where the property line is. Now, if I go down to the bottom of the curb cock, do you remember that? What's the purpose of the curb cock chair?
To prevent it from sinking into the earth?
Yeah, to prevent this from sagging down, right? It's just a block, curb cock chair. And then we have a coupling. Now, my animation, I failed to put the loop in it again because I was too lazy, but here's your corporation coupling. This would be the city tailpiece. That quite often the city tailpiece is actually 9 foot long, and they throw it right onto your property. So in case that leaks later, it's your baby. It's not theirs. So they make it quite sure they put it on private property. Now this is 2 inch. What kind of curb cock key would I use to close or open this, and how would it be done? Would this be
Quarter ton?
Yeah, this is only a quarter turn. It's only 2 inch. If this was like 4 inch or 6 inch, we'd use the commercial key that is opposite of normal. So this is still a quarter turn, right? It's only 2 inch. Back in the day, I would do this in copper, right? So now so if the service is 2 inch, here is the water distribution main right here, right? Right up until here. All this colored pipe is the water distribution pipe. What size would it be?
2 inch.
It'll be 2 inch too, because we're going to use the same 208.5. It hasn't split off everything. It's feeding the whole building. So this would be 2 inch, 208, and this would be 2 inch too. Both sized the same way. Well, let's go to the top floor. Let's just mix it up a little bit here. We'll go to the top floor. We already know the top floor is feeding 12.8 fixtures. So is there a cold involved in all these fixtures? The 3 bathroom groups and the ice machine. Yes, right? That's a singular cold, and these are combo colds, the bathtub and the sink, and the toilet is a singular cold. So they're all cold, feeds all of them. So that means that 12.8 fixture units, if I put an X on this cold line right here, feeding them all, what size would it be? Well,
3/4.
You go to your 2.4, right? 12 fixture units, you go to the 17, and it's 3/4 inch. Pretty easy, isn't it? So now,
If you don't miss any fixture units.
That's right. Well, that's why I've been told, and I believe it's correct, that when you are writing the red seal, the hardest part is counting all the fixture units on a full page commercial building and making sure you counted the private ones, the public ones, and looked at the right tables. So that is going to be the most time you're going to spend on my drawings or their drawings, is counting fixture units correctly, right? But now let's make it a little confusing. And now I heard they haven't done this, but let's say they do it. Let's say they ask you, or I ask you for this hotline, size this hotline right here. So how many fixture units are the hot fitting? Because it's not going to be 12.8. And these are bathroom groups. So how do you do it? So in other words, how many fixture units is this going to be that feeds? Well, that's got a hot, that's got a hot, toilet doesn't, that's got a hot, that's got a hot, that's got a hot, and that's got a hot. And the ice machine doesn't. So how do you do it? Well, let's look at the table for bathroom groups. Oh, it doesn't say really hot here, does it? So you're going to have to do them individually on hot. So you're going to have to lose the bathroom groups. So you're going to have to count the lav and the bathtub separately, the hot totals for separately. So if you count hot totals for this lav, this bathtub, this lav, this bathtub, this lav, and this bathtub, how many fixture units is that?
Is that 6.6?
Well, these are 1.4 each, right? And these are
0.7.
0.7 because they're private. So 1.4.
6.3.
So 6.3. So what would be the size of the hot feed for 6.3?
Half inch.
Just go to here and, oh, I've got to go to the hot one now, 1.5, right? So 6.3 would be 6.5, and there's your size, 5/8. That weird size that you'd have to pick if they pick. Does everyone see how I did that? I've heard it. If you get one hot question, I'd be surprised. One hot one. Most of them are cold services and cold branches because of that mix up with the bathroom group. So let's go down. Let's size something else. Let's size. Well, it's easy, right? If I was going to size the cold for this, the cold for this floor, we already told is 127 fixture units. That's just for these 6 lavs and these 6 toilets. 127 fixture units on the cold. Boom, you'd go to the 2. Oh, it's still 2-inch, right? Over 102. Is everyone following me? Are you getting what we're doing? We're just adding fixture units to the farthest one and going backwards. So let's do a harder one. Let's go here. We're still going to do cold. So I want to size this cold line right here. What am I counting? Well, I'm going to count everything to the left of that cold line, aren't I? And to the left of that cold line is going to feed this commercial kitchen, this, these 2 hose bibs, this 6.8 kilogram washing machine, and this hose bib, which is half inch public hose bib, and commercial kitchen sink. What's the fixture unit load here? If I wanted to size this branch, well, these are 6 each. That's 12. This is 4. Right, that's 16. Isn't this, is this 2.5? 18.5 and 4 is 22.5. I think if I've added that right, 22.5, we go to the cold, 22.5 go to the 30. That's a 1-inch. So that would be 1 inch right here, this cold line. Right? Any questions? That part's still the same.
Do you always have to do that first part to see if you use the commercial or the?
I led right into my next segue. So let's consider that. So I want you to open up your code books, and just before this chart, look on the page just before this chart to find this answer. And here's the question. It's in black. Note, if it is less than 2.6 kPa, so if your answer turned out to 2.5 kPa instead of 4.5, the system must be designed according to a detailed engineered design method. So where does it say that? Look for that in your code book. It's right in front of the chart. I think it's probably the last paragraph or the second last paragraph you should highlight. It's basically saying if it comes out to less 2.6 kPa or less, you have to consult a mechanical engineer. Have you found it in your code book? It's right before the chart. It's right at the bottom, I think, the last couple of sentences. You see where it is?
Yeah, I just found it. It's
So-
subsection E, I believe.
So it should be on mine, it's on page Division B, A89, and it's yeah, it's subsection B. So it goes, it's under where it's in bold, average pressure loss method, and go to the bottom of page 2, subsection B, and it's going to tell you that you have to consult with an engineer if it gets less. But guess what? What happens if they don't give you that as an answer? What happens if they don't give you that as an answer? Then this is what you do. If that is not an option, then choose the Captain Kirk method. So what am I talking about? If they don't give you an option of consult a mechanical engineer, what would be another way of figuring it out if it was only 2.5 kPa?
Simplified method.
Then you go not to the simplified method, you go to the small commercial method.
Small commercial, small commercial.
Right? So, but the small commercial method doesn't need all this information. If we wanted to size the same 208.5 fixture units, so if they gave you an impossible situation where it said they didn't give you consult a mechanical engineer, let's size it by the small commercial method. So what are the 3 pieces of information I need to size the same drawing by the small commercial method? Well, we know for the service anyway, 208.5 fixture units is the same. So what do you need for sizing the service on the small commercial method?
The property line over the
You
distance
need this, don't you?
meters.
You need this developed length, right? So this developed length, so we'll measure this one out because we don't know it. It's going to be, oh, sorry, it's going to be, oh, do that right, friend. From there to there, we're going to say 11 meters, and then we'll go up to there. 11 and 4, we're going to go 15 meters. So write that down, 15 meters, developed length from the property line to the building shutoff for doing the small commercial method, using a 208.5 fixture units. Well, what's the other thing? We need to know the KPA, don't we? Because we're going to use table A2632. So the KPA will be the same thing. The elevation is 2.5 meters. It really isn't on here. It's really about 4, but I'm going to say it's 2.5. So this is going to be the KPA. That's it. We just need that, right? 540. So which table are you going to use on the small commercial method? I think it's the one that's over 413 kPa, the last one, isn't it? Open up the tables. This is now in the back of the code book, A26, A26312A is the table you're using. And all we're going to do is we're going to use the last static pressure one, which is pressure over 413 kPa. Does everyone see that? So if you look at that last table, we're using the small commercial table, and I have 208.5 fixture units. I have for the developed length. What did I say the developed length was? 14 meters?
15.
15. So you have to go to the 18 meters on your table, and 208.5 fixture units, you go down to the 359. It's still the same, 2 inches. Isn't it? So even if you mess up and don't use the pressure loss method, in this case, we lucked out and it's the same size. It won't always be the same size. Sometimes it'll be 1.5 inches or a little bit smaller. It all depends. We just happen to luck out here, which is the same thing. So if you mess up on a question, there is a chance you could still come up with the same size. And that is the pressure loss method. So if it comes out to 2.6 kPa or over, you use table F, right? That's this table here. If it doesn't, then you should consult with an engineer. If that is not an answer, then use the small commercial method. You only need 3 pieces of information for that. You don't have to go through all these steps. Does everyone get it? Okay, well, we're going to stop playing this. I'm going to get out of this And now we're going to look at this pressure loss drawing. And I think I did it slightly different. I used different terms on it. Okay, well, let's practice on this. We're now going to use the same, it's the same drawing. I copied it. The only difference is the urinal flush tank, the cold water line they brought from this floor and I brought it from this floor. That's the only real difference. Everything else is still the same. These are going to be the same hose bibs, right? So what will be the service? Let's figure this one out. Well, if we figure it out, it's the same thing. This is oh yeah, you used 40 meters, so it's going to come out to 60 meters. The only difference is KPA here. They use 70 and we use a total of 20. So try and figure out this one on your own. All I'm doing is changing this. So look at the chart and look at this drawing. Now this drawing, this must be in the States because their water main is only 1 meter deep on this drawing. So, and ours was 2.5 meters. So you're going to use, I just want you to size the service on this, and their developed length is 10 meters. So using the chart, see if cable F will work on this information. It's going to be the same fixed unit load, 208.5. We've already figured out the same fixtures. So you can use the same fixed unit load, but I want you to do this first. So you got 35 and 35, right? So it says it's 550 kPa at the water main, and it only rises 1 meter. So what's the building shutoff pressure going to be? It's only rising 1 meter.
540.
So right there, that's your first figure, 540 instead of the 565 or whatever they're using. Or maybe it does come out at 540. So there's 540 kPa right there. Now you're going to lose, as it says here, 35 kPa, 35 kPa here through that water meter, and you're going to lose 35 kPa through this double check valve assembly. Right? And what else is part of the next step? Don't you have to do your system loss? So you have to do your elevation for the building shut off to the top unit. So let's take a look at it as this is all going to move with me. How many meters are we talking about?
14, another 140 kPa.
Oh, that's another 114. So then you're going to lose 100. So you're going to lose what, 140 kPa for system height. So we're going to put another 140 kPa here for system height. kPa that you're going to lose for the system height. And then the last one was that constant. What's the constant in your chart? The last one under brackets.
The minimum pressure.
105.
105. So I'm going to put another 105 here too. So 105 here, 105 kPa. Oopsie. kPa. So you're going to add these up together and subtract them from the 540. So what are those together? These four numbers. 35 plus 35 plus 140 plus 105.
335.
Is that 335?
We got your 140 and 70s, 210 plus 105.
315.
315.
Okay, so 315, we're going to subtract off of the static pressure at the building shutoff. 315. And what's that going to equal?
225.
225 kPa. Now we're going to take this new derated pressure of 225 kPa and we're going to divide it by the total developed length times 1.5. So now we got to figure out what's the total developed length on this drawing. Did I say anything on here? Let me see.
Is it
10.
40 or no?
Oh, that's the total height. Did I? Oh no, I say it down here.
Not there, the furthest
I see
fixture
it.
from building.
Yeah, I say it right here, 40 meters. So it's 40 meters to the furthest fixture. So 40 times 1.5 is 60, right? 40 times 1.5. So now you're going to take the 225 and you're going to divide it by 60. And what's that going to equal?
3.75.
3.75. What does it say on the chart? What is the units they're using for that?
KPA per meter.
KPA per meter. So 3.75 KPA per meter. And that is obviously over 2.6 KPA. So on this one, we would use the pressure loss method too. Right? And if it's the same thing, 208.5 fixed units, right? So it'll still be a 2-inch service here.
If they don't give you the meter and DCBA pressure loss, would you just assume it's the other table you'd use?
They will if it's this. Yeah, they won't do it the other. And as a matter of fact, I'm going to tell you, I just taught you the hardest, like the most complicated. There's a lot of steps to this, right? And typically, they just give you the KPA per meter. Typically, they just want you to remember 2.6 KPA. So they'll give it to you. Anything 2.6 KPA or over. Typically, you don't have to go through this whole chart. But I want you to know it in case they do. I want you to know how they did it. But typically, they'll just give you the final KPA per meter and they go, oh yeah, it's a pressure loss method, right? So this one is basically just like my animation, except the way they did the automatic urinal flush thing. Same totals, everything. And the only difference is they have different pressure losses right here. Okay.
So if it's exactly 2.6,
you still use the pressure loss method. Doesn't it say over 2.6? I can't remember. Does it say over? It says average pressure loss must be a minimum of 2.6 KPA. So if it's 2.6 KPA or over, you use table F. And table F is just like the simplified method. Well, you're using the same column up and down, either hot or cold. And most of them are cold, distribution branches and the service. So you're using 2.4, which is this 2.4 meters per second. So what you look for is, if you see a commercial building, you know it's either going to be the small commercial method or the pressure loss. If they don't mention KPA per meter, right, and they don't mention any pressure losses or friction loss or any of that in the question, it's small commercial method, right? If they give you more, the more information they give you is basically going to be a pressure loss method because you got to figure it all out, right? If they don't, if they only give you 3 pieces of information in the question for a commercial building, which would be developed length, system height, and KPA, well then, or fixed unit load, then you know it's the commercial method. Because they won't actually tell you to use the pressure loss method. They will just give you a drawing and give you the question and give you all the information. So for simplified small commercial, they're actually going to say, use the simplified method. It's easy in the question. And for small commercial, they're going to say, use the small commercial method in the question. It's easy. And then if you see a commercial drawing where it doesn't say anything, that means you're figuring it out to see if it's a pressure loss or a small commercial or mechanical engineer's decision, right? All depends how they word the answers. Okay, so I'm going to stop recording this.